was find the limit and simplify first. Okay, I have to start. So our function is 2 minus the absolute value of x over 2 plus x. Where do I start? Right, excellent. And I have to write the two possibilities, which are
X,
yes
X is greater than 0,
and
X
and
is less than 0,
and
negative X.
very good for x less than 0. Perfect. Therefore, this function has two possibilities. Furthermore, I have to make sure that this is clear. X does not equal negative 2. So there are two options. What are the options?
2 minus X plus X.
Very good.
X is greater than 0.
Very good. Excellent.
And 2 plus X plus over 2 plus X
Very good. Which is happens to be 1. For x
equal to less than 0.
less than 0, but not negative 2. Right? So then one more time, f of x is 2 minus x over 2 plus x for x greater than or equal to 0, and it's 1 for, I will write it in interval notation, negative infinity, negative 2, union negative 2, 0, because I need to incorporate that not equal negative 2. Okay, so I'm asked to find the limit as x approaches negative 2 from either side. So I will determine the limit as x approaches negative 2 from the left, and I will determine the limit as x approaches negative 2 from the right. From what?
From the left is 2 minus X over 2.
You're talking about 0.
0.
I'm not talking about 0. I'm talking about negative 2.
X has to be less than 0.
Left of negative 2 and the right of negative 2. From which of these two branches? Only one I can pick.
The second.
Right. So what is the limit of 1 when x approaches whatever you want?
1
So then what is this limit?
infinity 1.
Any questions? Any questions? Both sides, left and right, 1. The limit is 1. Okay. Next, we had the limit of x squared times cosine pi x. Of course, I have to plug it in, and I get 0. Cosine 0 is 1. How much is 0 times 1? Good. And the last limit, what do I do with it? Well, let me still keep this here. So the last limit, I meant h, I'm so sorry, of course. There is no x. There is nothing you can plug in, right?
But you had like put us in the middle of a problem and we haven't finished.
No, I'm sorry. There is no x in there. Minus 2 to negative 1 divided by h. So, sorry about that. Okay. So what do I do?
You know that 2 plus h
To negative 1.
is equal to 1 over 2 plus 1.
Very good. What about 2 to negative 1? Very good. Now I plug it in. 0 at the top, 0 at the bottom. There is hope for this limit. What do I do? I already plugged in. I got 0 over 0.
Try and find the common denominator.
Exactly. I have to find the least common denominator in the numerator, which is
2 times 2.
very good. It has to be the product of the two. This one needs a 2, and this one needs a 2 plus h. What about the top then? What do we get at the top?
Negative.
So 2 minus h, indeed. So now I have limit as h approaches 0 from negative h over 2 plus h multiplied by, because I have to flip this. These two go away. So now I can drop the limit operator in the next step. Because this approaches 0, the top is 1, 2 times 2 is 4, with minus in front. Any questions on this? Is this okay? Is this okay? Okay, the next one. We are asked to show that the limit x approaches 2 from either side of 2x minus 3 is 1 using the precise definition, or what it's called the epsilon delta definition. Is this true? I can determine the limit of a polynomial by simply plugging in it. It is true. It's 1. But I have to show. So this is equivalent to, for every epsilon greater than 0, I will find a delta greater than 0 such that every time I pick x close to 2, delta close to 2, this will always imply 2x minus 3, the function minus the limit, to be less than epsilon. That's where I start. I have 2x minus 4. I factor out a 2. I state the fact that this is the absolute value of 2 times the absolute value of x minus 2 less than epsilon. The absolute value of 2 is 2. All I have to do is divide by 2. And I obtain this, which tells us that delta must be epsilon over 2. And I have to reverse the steps.
I got that, but I didn't put the x. Well, in just the phrase, not the actual.
Oh, yeah, you don't have to use the symbols if you don't like to use the symbols. I'm fine. It's the same thing. Oh, yeah, of course. No problem there. Okay, and the last one was a piecewise defined function in which we were given the piecewise defined function. We were told to find a and b that makes this function continuous everywhere. So I have to write that 2a over x minus 2 plus bx is continuous on negative infinity to 0 as a combo of continuous functions. This has to be on the test. You have to write that. I have to write that ax squared plus 2b is continuous on the interval 0, 2 as a poly function. And the same thing with 3bx plus 4 is continuous on 2, infinity as a polynomial function. But now I have to study continuity at 0 and continuity at 2. At x equals 0, and later on continuity at x equals 2. So let's take a look. What has to happen for continuity at 0? Limit as x approaches 0 from the left must equal the limit as x approaches 0 from the right must equal f of 0. Limit as x approaches 2 from the left must equal the limit as x approaches 2 from the right must equal f of 2. So now let's identify of what? 0 from the left must be this. 2a over x minus 2 plus bx. 0 from the right. ax squared plus 2b. And f of 0 is here. ax squared, a times 0 squared plus 2b. Okay, what is the left-hand side? This one. When x approaches 0.
It's negative
Exactly. 2a over negative 2 is negative a, and this is 0. Perfect. 0 from the right in here. Excellent. 2b. And the same thing here. This is 0, so this is the same 2b. We do have the first equation. What is the first equation? Negative a equals 2b. Okay, now I'm looking at the other one. 2 from the left of ax squared plus 2b. 2 from the right from 3bx plus 4. 2 is here from 3b times 2 plus 4. So what is this? For a plus 2b. What is this? B plus 4. And what is this? 6b plus 4. What is the second equation that we just determined? 4a plus 2b must equal 6b plus 4. We have two equations. I will replace a, because I multiply both sides by -1, I will replace a by -2b in here. So 4 times -2b will be -8b plus 2b minus 6b equals 4. So this is -12, b equals 4, b equals -1/3. If b is -1/3, how much is a? B is -1/3. A will be 2/3. So a equals 2/3. So now I do have to go back and write the equation. I write the function from scratch. What is this? 6. Okay, here's my equation from scratch in which I replace a and b. So I have to write it f of x equals 2 times a, 4 over 3x minus 2 minus 1/3 x for x less than 0. A again, 2/3, x squared minus because b is negative, minus 2/3 for 0, 2. And the last one, negative x plus 4 for x greater to 2. And I will say, guaranteed to be continuous on exactly on everything. Guaranteed. We determine the only numbers that will make it continuous everywhere. So in preparation for the test, the first step would be to redo each and every problem we did in class. That's the only way. And then do the problems that are recommended and check the answer in the back. And of course, all these quizzes. Okay? Let's continue. I gave you 2 handouts today. Here's one. And I would like to talk about those. I don't think I need this one here.
Do you post the quiz on campus?
You mean the actual handout?
Yes, they
Yeah. But I returned all of them, and I will return this on Monday. But yes, absolutely, I will. Yes, all of them. Good. So it's a good point. Thank you. So we have 2 more things to discuss today, and one of them is the section 2.7, derivatives and rates of change. I have not defined what a derivative is yet. We do know what a rate of change is yet already, but I have not explained what the word derivative means yet. Okay, so let's go back to 2.7, derivatives and rates of change. You're probably already tired of this little graph that I keep going back to all the time. Okay, here's a function f of x. And here's a point. And this point is P. of a comma, its x coordinate is a, it's what, of course. And I would like to determine the slope of the tangent line to the graph of f at P. This is my question. I want to find the slope of the tangent line to the graph of f of x at P. Of course, you know the mechanism now. What will I create? Yes, so I will come up with another point to be understood that this point Q is extremely close to P, right? But I cannot make it here, nobody will see what I'm trying to do. So if this is A, what should this be? Very good, excellent. So then if the x coordinate is A plus H, for Q, what will be the y coordinate? As we know, this is just routine now. Of course, I will determine the difference quotient or the slope of the secant line PQ, and I need someone to dictate it. This is like for the fifth time, right? F of, yes, I meant to write A. Thank you so much. Thank you. Thank you. Yes, f of A plus H minus f of A divided by A plus H minus A will be definitely H, as we know. Okay. But this is the slope of this line. So this is the slope of the secant line PQ and also the difference quotient. Good. Stay with me. Now, in view of what we know and what we learned so far from the beginning of the class, I would like you to determine or tell me how to write, what to write for the slope of the tangent line at P. We have enough information to identify the slope of the tangent line at P. I'm missing, I need the key word in here, the key operator. Thank you. Exactly. That's what I was missing. We did not know this at the beginning of the class or the semester, but now we do. Of what? Exactly. Exactly. We did not have this limit operator because we didn't know what it meant. We didn't know its properties. We didn't know how to calculate limit from a function. We had no idea what it was. Now, this is it. So now, this happens to have another notation, and that is f prime of A. So we read this, read this, f prime of A. And this is the first derivative of f of x evaluated at A, which is also equals the slope of the tangent line at P, which is also the instantaneous rate of change of function f of x at P. It's all of the above. The slope of the tangent line, the derivative, as well as the instantaneous velocity or the instantaneous rate of change of that function at that point. So now, if you want to go back to the handout, to dot 7, so let me read this to you again. F prime of A is the first derivative of f of x evaluated at A. It's a number. It's not a function. It's f prime of a. A could be 1 or 2 or any number. So this is a number, not a function. It's also the slope of the tangent line at P. It's also the instantaneous rate of change, or the velocity, if you want, of the function f of x. If f of x is a distance, then this will be the instantaneous rate of change. So coming back to the handout. The tangent line to the curve at the point is the line through, which we already know. And the slope, for some reason, I don't know why h appeared here, but it's, of course, has to be right under the limit. So this is the derivative, provided that the limit exists. So if this limit is not a number, in other words, it does not exist, we will say that the function is not differentiable at that point. So this limit as h approaches 0 from the left and as h approaches 0 from the right, both have to exist and equal the same number. Otherwise, f prime of a does not exist. As we know that, right? We learned this so far in this course, till this point, that the limit as h approaches 0 from either side exists if both sides, if both limits, left and right, of 0 exist and they are the same number. Otherwise, this will not exist. Okay? Any questions? Okay. Now, I'm coming back again to our same graph. So I have here f of x. I have here the same point. You already gave me f of a. And this time I'm not going to call that a plus h or q. It's still q or any number, any letter. I'm going to put m, not to be confused with the other one. But this time I'm going to write x f of x. So this is a, and this is x. And I have this, I want to determine the same thing. My question is, how do I find the tangent at the slope of the tangent line at P? Can anyone give us the slope of the secant line PM? The slope of the secant PM? Perfect. Yes? Excellent. And now I would like you to tell me the slope of the tangent line at P. I only changed the notation on you. I didn't do anything else. But they are two definitions of f prime of a. This is one definition of f prime of a, and there is another one that you are going to dictate. I'm not going to write it because I know you know what I should be writing. So please tell me what I should be writing. Thank you. Careful, look here and tell me what approaches what. Approaches, of course. That's what it is, right? Of f of x minus f of a over x minus a. So please look at these graphs as many times as you need. And just remember, this is still f prime of a, the same thing, with the same interpretation, everything the same. So there are two definitions for the slope of the tangent line to the graph of a function at a point. Two definitions. They mean the same thing. As I said, we only change the notation. This is one, and this is the other. Of course, I should have included f prime of a. I would like to practice this. So if you would like to put it in here, it's the same notation, but I would like this time to write the other notation. So if we want to, we can write the same thing here first. H approaches 0 from distance or function f of a plus h minus f of a divided by h. But better, I would like to write the other form. So, or maybe we want to write both of them one more time. So this is limit as h approaches 0 from f of a plus h minus f of a over h. The other one is limit as x approaches a from f of x minus f of a divided by h. So that you have both of them together. I will explain this in a second. It's the instantaneous rate of change, the same thing. It's really the same thing. It's still limit as h approaches 0 from f of a plus h minus f of a divided by h. Okay, let's do 4, and then I'd like to practice. The derivative of a function f at a number a, denoted by f prime of a, is f prime of a, and I would like you to just put an arrow. This is already here, one or the other. Now you can ask me, when do I use this and when do I use this? First of all, it depends on the question. Secondly, in certain situations, for certain functions, this will be more difficult than this. For other functions, it will be the reverse. I have to look at the function. I can't say. But they both mean the same thing. Which one should you use? It doesn't matter. You choose, actually. But just be aware that sometimes this is a little bit more complicated in algebra than this one. Yes, please. Thomas?
Isn't the bottom supposed to be exponential?
Oh, yes, of course. Yes, thank you. Of course. Yeah, it's right here. Sorry about that. Thank you. Can't make any mistake here. That's good. I don't want to. Thank you. Okay, the tangent line to y equals f of x, which is the function, at this is the line through P whose slope is equal to f prime of a, the derivative at a of f of x. I would write the derivative of f of x at a. Perfect. On page 151, let's choose a couple of problems and work with this definition. I would like to look at, I think this is one homework problem, but that's okay. I would like to look at that graph. So the graph is problem 17 on page 151, and I'd like to look at this. For the function g whose graph is given, arrange the following numbers in increasing order and explain your reasoning. Okay, what does g prime of negative, oh, I'm sorry, 0 is 0, I can't do anything. So what does g prime of negative 2 mean? I have to look where x is negative 2, which it happens to be here. And g prime of negative 2 will be what? Slope of the tangent line at that point. Okay? I'm going to draw, I know this is going to seem very arbitrary to you, right? I'm going to draw a right triangle. And I'm going to say, I think it's, first of all, it's positive. The slope is positive. I think it's probably about, maybe this is 2, the rise is 2, and the run is 1, maybe. I'm going to say approximately 2. It's an approximation, of course. So I'm going to say that this is 2. G prime of 0. Slope at 0. Obviously, it's a negative number. So I'm going to say, well, it appears like these two are kind of equal. So I'm going to say negative 1. G prime of 2, here's a 2. So obviously, it's less steep than this. This is this, and this is this. Well, I'm going to say it appears approximately 1. G prime at 4, so this is the slope. obviously much smoother than this, right? This is smaller than this is more acute, this is less acute, and this is definitely less than 1. So I'm going to say, if this is 1, this appears to be about 3. So I'm going to say this is 1/3. So now I have them arranged in order. This must be -1. Then this is the 0 will be next. Then the 1, I'm sorry, 0. Then 1/3. Then the 1, and then 2. Any questions here? Does it make sense?
That's it.
That's it. It says just put them in increasing order and explain your reasoning. And my reasoning is this. Definitely this is negative. Definitely this is positive, this is positive, this is positive. This is definitely the highest of these three. The steepest. This is the next steepest, and this is definitely much lower. You may say, you may not want to give a specific numbers, but definitely this must be the first, 0 must be the next, this must be the third, this must be the fourth, and this must be the fifth. Any questions? Okay, so now let's find f prime of a for, let's say, 30. On page 151, we want to find f prime of a. We are given the function f of x equals x to -2. Say it again. No. You are on the right track if you remember the formulas, but it's -2 times x to -2 minus 1. So it's a different story. Okay, we cannot use that at this point, and not in this test. You can check it on scratch paper, that's fine, but you have to use a definition. I remember that we have two different definitions. They're not different, really. Two definitions for this. So one definition is limit as age approaches 0 from f of x plus h, I'm sorry, a plus h minus f of a divided by h. The second possibility is f prime of a, which is limit as x approaches a from f of x minus f of a divided by x minus a. These have to be already embedded, right? We've discussed this so many times. Okay, which one would you like to use? The top. You want to use a second. That's fine. That's perfect. So we want to find f prime of a with this definition. We chose this one. Perfect. So please dictate limit as x approaches a from
Negative mean x to -2.
right, which is
1 over x squared.
good, minus f of a,
1 over a squared.
very good, over x minus a. What is the first thing I have to do when I determine a limit?
Try to find
Plug it in.
the form.
Plug it in. 1 over a squared minus 1 over a squared over a minus a. What is this? Good. Okay, perfect. Now I go back to the top, and you will tell me what to write or what to do with the top. And before we continue, since I got 0 over 0, I know for sure that a factor will come out from the top and the same factor will come out from the denominator, so I can cancel those. I can say that the limit exists till I get there, but there is definitely a factor of blah at the top and a factor of blah at the bottom that must go away. Which factor will that be?
X minus
Of course. So then
common factor, common denominator.
a squared x squared. So we need here an a squared, we need here an x squared. So it's a squared minus x squared. Good. I don't like the top because it's not in descending order. So I'm going to reverse, factoring out -1. And this is over 1 times 1 over x minus a. what am I going to do next? So I copy the fraction from the top. I factor out -1. And then I copied the fraction from the denominator, flipping it, of course. Exactly. I'm going to factor this. So I have limit as x approaches 0. How do I factor? We have an agreement on this. Very good. Divided by x squared, x minus a. And exactly what I expected is going to happen. What is it? What am I expecting? The factor of x minus a to go away. That's the reason why I got 0 over 0, because of that factor. Sorry. Limit as x approaches a. Good. So then now I'm ready. I'm ready to plug in a, and this operator will go away. So what is the answer? Negative. Very good. 2a over a squared times a squared. One of the a's will go away. And the simplified form of the derivative of this function at a is -2 over. Good. So Ian, what you meant, you said this, and I would have agreed with -2x and -3, which is this. But we don't know that yet. We will in the next chapter. But you're on the right track. Perfect. I like to look at (20) on page 151. If the tangent line to y equals f of x at 4, 3, if the tangent line to the graph at 4, 3 passes through the point 0, 2, find f of 4 and find f prime of 4. So let's read the question one more time. If the tangent line to the graph of the function at 4, 3 passes through the point 0, 2, find f of 4 and f prime of 4. So I'm going to just picture something in here to see if I can make up anything. So there is a graph. There is a point 1, 2, 3, 4, 1, 2, 3 right here. So if the tangent line to the graph at 4, 3. So I'm going to say this is the graph of function f. This is the point 4, 3. And they say that the tangent line to, yes, goes to 0, 2. So my graph is not perfect. So the tangent line, I'm going to redo it. So 0, 2, 1, 2, 3, 4, 3. So this is the tangent line. And now I'm going to fake the function. So this is my function, and this is the tangent at 4, 3. And this is the point 0, 2. So if the tangent line to the graph of f of x passes through 4, 3, that passes at 4, 3, passes through the point 0, 2, find f of 4. Of course, f of 4, there is no discussion. This must be 3. F of 4 must be 3. But now we're asked to find f prime of 4. Exactly. So f prime of 4 will be the slope 3 minus 2 over 4 minus 0. It's the slope of the tangent line. So it's 1/4. Very good. So now we know what the derivative is at the point. What is it? The slope of the tangent line at that point. So if this is the graph of a function, and this is a point P, this this slope is the same thing. So let's say it's a f of a, f prime of a. So the slope of the tangent line at P, tangent at P, is nothing else but f prime of that value of x. So now, when does f prime of a not exist? When?
F of A.
So in other words, I'm really asking this. Is f of x always, is f of x always going to have f prime of a at any point? Here are three situations. Here's another situation. These are all functions. And here's a third one. So one more time, the derivative at a point is the slope of the tangent line at that point. Both sides on the slope, both sides have to approach the same number. So if you say f prime of a is 2, the limit of the difference quotient from the left has to be 2, and the limit of the difference quotient from the right has to be 2. In this situation, at this point, let's say 4, does f prime of 4 exist? I have to show you a tangent, and from both sides of the point, the tangent is the same. At this point, I have this tangent, and at this point here, I have this tangent. Do they have the same slope? Are they the same? No. So I will say f of x is not differentiable when it is not what? Thank you. If a function is not continuous at a point, it cannot be differentiable at that point, period. It has to have a unique tangent. Unique tangent. It does not have a unique tangent. It has two tangents. This one, it's called a cusp, or even corner. So let's see what happens at this point. There is a tangent here. There is a tangent here. At the cusp, even if the function is continuous, will it have a different derivative? Will it be differentiable at this point, let's say at 2? No. Cusp and corner imply f prime of 2 does not exist. For the same reason. The limit of the difference quotient on this side is positive, and the limit of the difference quotient on this side is negative. Therefore, they are not the same. Third situation. So the first one is discontinuous function. The second one was a cusp or corner. The third situation is this. Look at the tangent at this point. So in other words, what will happen here, it would be this. The result of this limit, or the limit, will not exist. It will not be a number. If this is not a number, if this limit is not a number, then f prime of a does not exist. It will be infinity. It's a vertical tangent. A vertical tangent, and when a function has a vertical tangent, it's not differentiable. So that's a third situation, so it's a vertical tangent. So f prime at that point does not exist, because that limit is not a number. It's infinite. So I'm getting at actually the last section, and that's what it was. Corner, discontinuity, and a vertical tangent. So these are the examples. Corner or cusp, not differentiable. Discontinuity, jump or otherwise. So in my example here, there is a gap. And vertical tangent. This is the definition. This is the exact difference quotient, and the limit of it will be the function. So this is a function now. And the function will give us the slope of the tangent line to the graph of f at any point. These two definitions were specific. These two are specific for a particular point. A point 5, 3, 2, a. Specific for a particular point. The answer is a number. Here, the answer is no longer a number now. And this has only one definition. So let's write this down. So the derivative as a function. Derivative as a function. So we have two definitions for f prime of a. F prime of a, two definitions. Either h approaching 0 or x approaches a. For f prime of x, and these are all numbers. For f prime of x, we have only the difference quotient as we know it originally. F of x plus h minus f of x divided by h. And what does this represent? And this is very important. This is a function that gives the rate of change, the instantaneous. The instantaneous rate of change at any point on the function, where the function is what? On the graph of f of x, where f of x is careful, this function is continuous, but it's not what? Differentiable. This function is continuous, but it's not differentiable at each and every point. So where the function is exactly where the function is differentiable. So differentiability, continuity. Which implies which for sure always, and which does not for sure always implies the other one. Yes, always. If I say that a function is differentiable, you know it's continuous. But if I say it's continuous, can I conclude that it's also differentiable? No. So the other way around, no. No. But if a function is differentiable, it will always be continuous. Okay. So here it is. A function is differentiable at a point at A if f prime of A exists, and it is differentiable on an open interval if it is differentiable at each point on that interval. It makes sense. So it is differentiable if f prime of A exists, and it's differentiable on an open interval if it's differentiable at any point there. And what you just told me is correct. If f is differentiable, then f is continuous. How can a function fail to be differentiable? In these three situations. When the function is not continuous, when it has a corner or a cusp, or when it has a vertical tangent. I like to practice. Now, I recommend you look in your book as well. For example, I really like this, what they showed here. They showed a graph of a function, and we're going to do that too with an example. I still have, the time just flies in this class. I don't want to forget, I need 4 hours back from you. 2 for Labor Day and 2 for before Thanksgiving. I can't miss 4 hours. So I'm willing to come and meet with you on a Saturday, if that's an option, on a Tuesday evening, 4:30 to 6:30, but I need to recover those 4 hours. So please think and tell me on Monday. We have to make arrangements. Is Saturday okay, 12 to 2 for everyone? Yes? No? Is Tuesday evening, 4:30 to 6:30? Tuesday evening? Tuesday evening, 4:30 to 6:30 here in this room?
I can make that. Yeah, that doesn't work for me.
Does not?
I can make either of them.
So you cannot make the Tuesday.
What is it?
We're here.
Today.
Friday, 12 to 2.
I can do Friday or Tuesday. I'm not busy.
I can't do it.
Say it again.
This Friday?
No. We all have to set it up. It doesn't have to be this week. No. I just want to know which day will be the best for you. I can't miss 4 hours in this class. As you see, it took me 5 weeks to finish one chapter. I can't. So Friday is not going to work for everyone? No. Tuesday night, one more time, 4:30 to 6:30. How many people cannot make a Tuesday? 2 people cannot make a Tuesday. How many people cannot make a Saturday? 12 to 2. Earlier Saturday. Nothing on Saturday. No hour on Saturday. No. Saturday, no. Yes, no, nothing. Okay. We'll have to compromise somehow, but as I said, I need 4 hours back. Okay, so the graph of a function is given, and they're asking us here, graph the derivative. I can graph the derivative with accuracy, but I can graph an approximation. How do I do it? In certain points, I determine the slope like we just did on the other problem. Definitely the slope here is 0. So there is a 0. Definitely here the slope is 0. So there is another 0. Definitely here the slope is 0. So there is another 0 for the function, for the derivative. Here, like I just did, they came up with a triangle. And they said, okay, it appears that this is 3 and this is 2. So at this point, this is 1.5. Like this one was 0 here and 0 here and 0 here. Here, it's definitely positive, and they calculated it, it's 3.5. 3 halves, which is 1.5. Definitely on this portion, they're all negative slopes. Okay, here's the function. The derivative is negative. From huge negative to smaller negative till 0. Now this is positive. This is positive. So then the slope is positive and does what it does, but it has to come back to 0 because right here is 0. So as you see, it's positive. Then it starts here. It's the biggest. At this point is the biggest. And then it starts smoothing out towards 0. Now it becomes all negative between these 2 points, between this 0 and this 0, the slope is negative. Any point you want to draw the slope, it's going to be negative. Here somewhere is the biggest, negative. Somewhere right here. And then it's becoming smaller and smaller towards 0, not as acute. Of course, all the way here is positive. All slopes are positive. This is the biggest slope right here. That's why it's the highest. All the way. Okay, so what I would like to do now, I still have 6 minutes. Okay, I would like to, and these are examples again of vertical tangent, and I would like us to choose an example. Find the derivative of the function or a graph, whatever you feel like it. Page 163. Let's do a function. Okay, very good. Which function? So this is again the same thing. Which one? 21 to 31?
26.
So as you see, g of t equals 1 over the square root of t. We're asked to find the g prime of t. There is only one definition for g prime of t, and it's the same thing that I've been torturing you with all along. So how do I find g prime of t? If we haven't written this like 15 times, we haven't. So what do I write?
F of A. Then SH equals 0.
Very good.
F of A. F
So let's write it like this first. So g
T plus H.
t plus h minus g of t divided by h.
The other one?
No. For f prime of x or g prime of t, there is only one definition. The answer has to be a function. So limit SH approaches 0 from 1 over the square root of t plus h minus 1 over the square root of t over h. I plug it in. What do you expect? I shouldn't even look when I plug it in. It has to be 0, 0. Right, because the limit will be a function and this will exist. Okay, good. So then limit, so it's 0 over 0, of course. Limit as h approaches 0. The numerator. What do I find now?
Square root of T plus H. Times.
Exactly. Good. So then this one needs the square root of t, and this one needs the square root of t plus h. So the square root of t minus the square root of t plus h. What do I do now? We had this again over and over. I'm going to flip h. So I have limit as h approaches 0 from the square root of t minus the square root of t plus h divided by h, the square root of t, and the square root of t plus h. What do you expect eventually to go away? And I should have asked again, and I forgot. What is that factor from the top that will go away, and the factor from the bottom that must go away? I got 0 over 0. So what is the factor that will have to cancel from the top and the bottom? Exactly, h. Perfect. So how do I handle this? Yes.
So that would be square T plus
Very good. So limit h approaches 0. I will copy the denominator. And please give me the numerator.
so that would get you H or
Yes, so it's going to be t minus t, careful, minus h, because we have to distribute. These two go away. Do not cross in a sum, so we have to write it one more time. negative h over h the square root of t, the square root of t plus h, the square root of t plus the square root of t plus h. Now I'm allowed to finally get rid of what the problem was. That was the problem. That factor of h from the top that created 0 over 0, and the factor from the denominator that created 0 from the. And now I can drop the limit operator after I plug in what? Exactly. So this will be 0, and this will be 0. So the numerator is negative 1, and the denominator is, how much is the square root of t times the square root of t? T. And how much is the square root of t plus the square root of t? 2t the square root of t. What is this? What does it represent? It's the derivative function that will give what? The slope of the tangent line everywhere on the graph of the square root of t, wherever 1 over the square root of t is. So what have we studied in chapter 2? The difference quotient. That's all we did. We didn't study anything else.